right? Because constant velocity also means zero acceleration. So you have net force zero idea. Yeah, so you will look into all this scenario. So we'll move on to this lift system first, okay? So I will tell student now, okay? Actually, maybe now, pandemic so nothing you can do. Let's say you live in a condo or flat, then you have lift, right? So you may go and have a try also, right? So what the student do is he actually bring a weighing scale into the lift, and then he press up and down to check, okay, whether his weight changes or not. But most of the time, our balance is using in kg lah, right? But this scale is using Newton one. So the scenario is like that. So basically, right, the first concept itself, you need to see the title. Like I show you all here, is showing what? So the first scenario is when he take this balance inside, and then he just don't move, okay, just at rest there, okay. Then later on, or he actually press up and down, but this lever actually move very slow, like constant velocity, or constant velocity up and down. So this is the scenario given, correct? So again, based on this title, correct or not? So what you can see is the leaf is at rest. So every time when you want to form equation, you need to know what is the force acting on the person. So like this case, what means the net force acting on him is actually zero because of this statement, at rest, constant velocity. Okay, paguna, okay, dan halaju mala. So what happened is you should know one concept whereby acceleration is what? Zero. So if acceleration is zero, right? Can y'all tell teacher what should be the relationship between this R? Okay, by the way, this weight, you all know lah, is refer to gravitational force, or weight, W equals to mg. This R is actually any object on a surface you will acted by a normal force. But in this case, this normal force, normal reaction force, right, is also the weighing scale reading. That means is also referred to that reading. Okay, so based on this idea, can you all tell teacher what happened to the relationship between this normal force or the scale reading with this weight or not? There should be what? Yeah, so in this case, the concept will be the two reading will be the same. Let's say this weight of the student is 50 Newton. That means your normal force must also be what? 50 Newton, understand? But they're opposite direction. So again, you denote lah. Downward is negative. So you get back zero, right? F net equals zero. So therefore, we can just straight away say the scale reading is equivalent to the weight of the student. That means there is no change in weight lah. There's no change in weight. Okay, but there will be slight difference when you press the leaf upwards. So when you press the leaf upward, right? That means, of course, this leaf now accelerate. The problem is now accelerate. Okay. Now when this leaf accelerate upward, right? Okay. First, can you tell teacher where is the direction of net force first or not? If your acceleration is up, is acceleration is upward, where is the direction of the net force as well? Okay. You see, I use number easy for you one. Okay, so if I want this thing to fly up, what happened to the upper force compared to the bottom force? If I want this thing to move up, that means A should be bigger or B should be bigger? A must be bigger value, correct or not? Then only makes sense, the thing will move up according to the direction of acceleration. Yeah, so example only is 10 and 2. So your net force is 8, but 8 Newton where? Upward, because your acceleration is upward. So that's why when this leaf is moving upward, right? So therefore, your net force is also upward. And then based on this relationship, again, can you tell teacher, now R should be bigger or W should be bigger? Which one is bigger? Your weight is bigger or R bigger? Because you do know all this idea, you cannot form relationship, then you cannot form equation one. Very good. It's like I give you this scenario, right? Obviously, 10 and 2 is bigger. Of course, upward, right? 10 is bigger. Yes. So in this case, your R will be bigger than mg. Okay. Then how do we form equation we always back to this formula, F net equals to MA. Okay, so where do you get this net force? This net force is actually come from the relationship here. So we always assume bigger force will be positive. Smaller force will be negative. So can you all tell teacher, should I write R minus mg or mg minus R? Anyone have any idea? Yeah, you should use bigger. R is bigger, correct or not? So therefore, you will actually have, wait, I should straight away use this one. R, you all told me one, correct? R minus mg equals to MA. So therefore, R equals to what? Mg plus MA. So generally, when you press upwards, you will find yourself heavier one. I don't know you all ever experienced this idea or not, unless you really always move up and down using lift, or else you wouldn't experience this lah, correct? Unless you stay in condo or you always go KLCC or what. Nowadays you also cannot go shopping, right? Correct? Also sad, right? So basically the idea behind is like that. You may find yourself heavier one. Or another idea I always tell students, why you feel yourself heavier is because you're against gravity, right? So when you move up, you will find it harder a bit. Means like seems like heavier. But this is just you jump in the lift, you will finally still reach downward due to gravity, right? You change. So there's no difference one. Okay, now, so what if now the other way around? Okay, so this one, general idea is you feel heavier, right? The boy feel heavier lah. So if any of you want to gain weight, you don't need to do anything, right? You just press lift, then go up lah. Then you suddenly gain weight already. So of course, this is what we call it as apparent weight also lah. This is not the actual weight of this student. So next scenario is now the lift now accelerate downwards. Okay, so if they accelerate downward, so the idea is now your A is what? Downward. So similar like opposite from this case only ma. If your acceleration is downward, your net force now also in which direction? F net is also downward, correct? Not? So in this case, who is greater now? Is R greater or mg greater? Yeah, mg is greater than R. So how do you form the equation? Same one, it's actually start from F net equals to MA. So what is your net force? In this case, teacher say bigger value minus smaller value. So you will have mg minus R. Or hence you will have what? Rearrange, or you will have R equals to, I actually move R to the other side. I bring MA to the other side. Notice or not? So you will have what? Mg minus MA. Which means this student now, he generally will feel what? Lighter. How do you experience this idea? Again now, this 2 year memang you all susah lah, tak boleh pergi mana-mana. So, but I believe you ever been to theme park before? Did you? Right? Any of you like to ride on the roller coaster one? If you imagine this idea, this is already fixed one. Xuehui is a formula. F net equals to MA from Newton's second law. So what is this F net? Is based on what you see here. It's always start from this. That's why you need to be clear on the previous lesson. That's why I take some time to explain. So if you're ever ride on the roller coaster, okay, of course, you will lift up first. The moment the roller coaster move down, how do you feel? You were like, wow, flying away like that, or you suddenly feel so light. So you remember this idea. What means how you what means, let's say you're very confused with how I form this formula. Important you remember the final formula. Understand? You remember the final formula. If the thing accelerate up, you will feel heavier. That's mean mg plus ma. If you all move down, then mg minus ma. So this is the thing that you all need to take notes. Is it all right? Good? Clear? Can all? So yeah, you all write it down already. Can I move on next? Then I guide through how do you form equation for pulley system. Okay. So next idea will be pulley system. Okay, there are two methods to solve the questions, but I will use one method which actually apply for most of the scenario, and it's not super confusing, but you all need to good in solving problem involving simultaneous equation, or you all need to solve the question using simultaneous equation way. Okay, so now I move on with this. Yeah, correct. Okay, so we move on. Oh, sorry, I forgot to answer this question, but your friend answered already. Yeah, true also. Okay, so now for this case, how do you solve the pulley system question? So same thing one, okay? Now, you need to identify what are the force acting on this system. Like this case, I'm very nice. I show you the arrow already. That means you surely have what? Weight. Downward, okay? M1, M2. I give you mass out. You need to find out what is your weight, correct? W1 and then W2. Then remember or not, I told you all the direction of tension is always away from the object. Basically, they have two directions, but then when we solve problem, it's easier, or you only see one arrowhead, understand, away from the object. Okay, now this method is slightly longer. Some people who are good, you know another method one, you can go ahead. Now I'm teaching that one, that general, or apply for all the cases. Okay, so then next thing, after you label the force, right, you need to identify the direction of acceleration. Now, 7 kg and 4 kg. Of course, I assume this is left side, this is right side. What happened to the acceleration on the left-hand side? Who will pull who downwards? M1 will go down or M2 will go down? Obviously, left-hand side or right-hand side? Left, right, correct or not? So that means next step, you all need to label acceleration. The acceleration is here down. Okay. Then next one, this side left, right-hand side, what happened? Right-hand side, of course, acceleration will be what? Upward lah, correct or not? Okay. So now all these things labeled correctly already, all right? Then we need to split the system into two parts. We split the system, right, into left-hand side and right-hand side. Also, I make it into the red box and also green box. Then later on, you're going to form two respective equations. Okay. By the way, let us find the weight first. So later on, we straight away can do the substitution straight away. So formula for weight is equals to mg. Now, most of the old reference book, they will assume g is 10. But then your new syllabus, memang g is 9.81. If the question didn't say anything, you really need to use 9.81. Unless they say, please use the g as 10, or they give you weight instead of mass. Clear or not? So I want you to be familiar. Also, I use 9.81 because I didn't mention in the question. Please use g equals to 10. Understand? Okay, so now this one will be what? 68.67 Newton. Then same go for your W2, 4 times 9.81. But of course, there will be a lot of decimal point when they didn't use 10. But this is a more accurate value. That's why they want you all to familiar with it. Okay. So now we form equation. You just need to look at the red box. That means the green box, right? You ignore first. You don't see anything first. So I cover it so you will not confused by this. Okay. Then now you need to form equation, and the equation is similar like how I taught you on the lift system one. Okay. Now your acceleration is downward. So your weight is greater than your tension, or your tension is greater. You all just need to tell me T or mg. Which one is greater? Mg or T? Good. Very good. All of you answer correctly. Okay, more than 10 people answer me already. Mg is greater, correct? Because the acceleration is downward, all right? If you don't know one, you label here. So your concept, your mg is more than tension. So I want to form equation, So the equation is always come from this, F net equals to ma. So therefore, who minus who? Mg minus T or T minus mg? Mg minus T in this case equals to ma, correct? Now again, you need to sub everything correctly, okay? But I write in general first, mg minus T should be equals to MA, but I need to sub the accurate one. So my MG I already got, right, which is 68.67 minus tension unknown equals to what? Mass. What is the mass? Don't confuse mass and weight. So here is 7. And then A is also unknown. So I form first equation. Okay, then do the same thing for right hand side, the green box now. So now I shift here. So same idea one. Now you look at this system. R is bigger or MG is bigger? Tell me again. Those of you who know yet answer me just now one. Your chance to answer. Who is bigger now? R or MG? R, yeah. If you know yet answer, you can always answer just to see whether you understand the idea or not. Very good. So now R is actually. Sorry. Why I say R already? Tension. I use the wrong term. Sorry. I should say T instead of R. Later on confuse you again. Sorry. So in this case, your T is bigger than mg. So my equation also same thing. I always start with this one. F net equals to MA. But in this case, what is my F net? So I will use the bigger one minus. Understand? So you cannot use mg minus T. Then it will be wrong. It will be T minus mg equals to MA. Clear? So in this case, T is unknown. Minus mg, 39.24 equals to what? 4A. Now, next idea, you're going to solve these questions using simultaneous equation. You can use elimination or substitution way, up to you. Can you all finish, okay, and tell teacher what is your A and T respectively? This is next part. I want you all to try, okay? At the same time, I also do with you, I will use elimination way. So if I want to eliminate T, I should use plus, correct or not? So this is maths part already, clear? Wow, some of you very good, okay? Very fast. Already get the answer. Well done, okay. So let's check, so more people give me the answer in the chat, Okay, good. Eunice, your acceleration is correct. Yeah, I think your tension also correct because another student give the same answer as you. Very good. Okay, then next step, of course, your sub what? Sub, or maybe you use another method to solve it, but it's okay one because I use this one is like it apply for all the scenarios, so no need to confuse. Okay, so you sub A into any equation, right? 1 ke, 2 ke, or sama punya. Okay, then you will have the tension. 4 times 2.675 or plus 39.24. Yeah, there is recording. Then you will get 49.94. Did I miss out any one questions? Okay, all good. Can so this is how you all solve the questions. Of course, there is another easiest way, but that depends on cases. Okay. The other easier way is even though you use one formula, but then later on when come to if you want to find more information, like this case you need to find both tension and acceleration. So you memang form two equation. You can also use one equation first. Later on you form one equation will do. That method also can, but I find it like sometimes you'll be confused, so I teach you one method will do. Okay, so everyone write it down already. So I move on to the next. While waiting, some of you may try do the labeling on the second diagram first. But it will back to the normal also. Okay, I can show, right? All of you finish first, okay? can, or you screenshot, yeah, it's like that lah. We have 1 hour, 30 minutes, very limited only, but I need to teach 1 month things at one shot, okay? Yeah, so that's why sometimes teacher also rushing a bit, cepat sikit. Okay, so now another bit method is actually straight away, you will use F net equals to MA. So this net force, but this one you can find acceleration. Let's say the question only asks you find acceleration. So what is the net force from this system? Left side, you have 68.67 weight. Right side, you need to use a weight idea, cannot use mass. So your net force is generally W1 minus W2, correct? I will say, you can imagine that like this pulley system, you pull the two string this way and this way, because normally see the force all left, right like that, similar idea only. So of course your left side is greater than right side lah, but then this idea is not really correct one, but want you to get the idea, correct not? So equals to MA, but when you use this M, right, it's actually 7 plus 4. So you can straight get your acceleration already. Notice or not? 68 minus 7 is 68.67 minus 39.24 equals to 11A. Notice or not? It's similar like one of your equation that you form. Then you can find your acceleration straight away. But if you want to find tension, you still need to find out one equation respectively from either side. So this is another method lah. If let's say the question only asks you find acceleration, you can straight away use this way. But then I worry students sometimes confused with the mass part. Like you forgot to total up the mass. So you need to be careful. Just like that. This is second method. Okay. So we move on to the next. So next questions. We will have an object on the table and then they're being pulled down. Again, you need to label the given force first. So you must have weight. Later on we sub. Then you have tension, correct? And then you read the weight is then released. Find the tension in the rope is the friction on of 6 Newton against. That means this case got frictional force. So your frictional force will be against the block here. I write FR, okay or not? FR equals to 6 Newton. And then again, now your arrowhead potential will be left or right. I will say again from object away from object. So it's this side. Then next, okay, even though this case now 2 kg seems lighter than 3 kg, but because you have this pulley, that's why pulley can make your less work. They're able to pull the object down. So they still have the direction of acceleration. The acceleration will be what? Toward right hand side and move down. Understand? That means the 2 kg is still able to pull the system down. Again, you're going to form 2 equations, right? So the first equation will be over here. I box it blue box. And also another box. You can say not opposing the motion of the object tension. Is away from the object, away from the object. Then you need to solve the problem, then only you will know, okay, whether it happened or not. Can the acceleration produce or not? If you have pulley system, they surely will make this object pull the other object down. Evan. Yeah, so this is the idea. Or else they won't ask you to find the acceleration. Okay, Cam? So again, we're going to form equation for blue box. Maybe you all want to try yourself. You all just need to tell me what minus what equals to MA for first equation. Okay. Some people start to questions. Teacher, did we need to involve the weight of this 3 kg block? Now, the weight direction is downward, correct? But remember, any object on the surface, you have normal force. So this R and W have been cancelled out each other. So when they are on a surface, right, we don't take into account of the weight of this block one, unless you are using the first method. I showed just now the other method that I show you. That's why I say that method sometimes it's kind of confusing because you need to include mass or you need to include mass. So some students that they are not firm, they will be confusing. So I always use this one. You split the system into 2 parts. Okay, easier. Wow, okay, got student tell me the answer already. Very good, okay. T minus, so in this case, there's no mg for horizontal. It's frictional force. Yeah, so it's in general, it should be T minus frictional force equals to MA, correct? Yeah, then of course you straight away sub lah. Your frictional force is 6. T minus 6 equals to 3A. First equation. Then next, let's see the green box. Okay, form the equation for green box now. Again, your tell teacher what minus what now. Okay, we find out the weight first also. 2 times 9.81, you will get 19.62. Okay, very good. Also, that's why it's important for you to know where is the direction of acceleration. Yeah, so in this case, your weight should be more than your tension, because acceleration is downward. So you have 19.62 minus tension equals to 2A. Yes, 2A. You split already, you don't add the system punya total mass, then it's confusing. Okay, then again, you do the elimination way, correct? Should be equation 1 plus equation 2. Yeah, so again, you all find out the final answer, then teacher counter check. Oh, wow, some of you very good, very fast. I still dreaming, negative 6 plus 19.62 equals to 5A. So A, did you all get your acceleration 2.724? This is what your friend have, okay, on it. Yes. Then again, sub A into 1, okay? Okay, then you have what? T equals to 3 times 2.724 plus 6, correct? Yes. Now, Ethan, because memang this year they emphasize whatever question, if they didn't mention, please use G equals to 9.81. So you ask me if you use 10, will they give you mark? I cannot guarantee whether it's acceptable or not, but they already emphasize. So that's why I advise you, or if the question didn't say use 10, then you have to use 9.81. It's for your own safety law. If you minus 1 mark, also you will cause your grade to be lower 1 grade one. You never know the 1 mark or 2 mark important or not. Okay, of course, if you accidentally you forgot, then you hope that because a lot of people also make mistakes, so they actually accept them for the first year. But I cannot tell you, they already emphasized. Please remind your student to use 9.81. And normally in formula list, they will show one. You all check. The first page is formula list. And like I told you, I also cannot tell you, is all the equation or linear motion they give or not. Because everything this year you have to derive yourself. No, it's not accurate enough also, Lishin. 9.81 means 9.81. Don't simplify it. 2 decimal point. Okay? I will say you want an extra option, can. Then you take your own risk. But not, I didn't taught you that way. Okay? Yes. But if the question say use G10, you use G10, you don't go and use 9.81 pula. Susah kan sendiri. So far, so good, Yeah, then we move on to the next idea. So I hope that you all know how to form your own equation and then solve problem based on pulley and also lift system. Okay, so let's move on to the next part. Okay, then you can try on the exercise again. So last part is on elasticity. Okay, right? So any of you remember what is the meaning of elasticity? I guide through first, then I show you all the answer one shot. What is mean by elasticity? The ability on the object to what? Last SPM asked this question, a lot of students wrong at the last part. Elasticity means what? The ability of an object to return to its original shape or size after what? Very good, Lampong. Accurate answer. After being stretched, wrong. After being compressed, wrong. after the applied force or external force is being removed. The back part important. Yeah, because after stretch or not necessary one, okay, you must be the external force being removed. Okay, yes. All later on, teacher show you all the full definition. Then what is the meaning of Hooke's law? So Hooke's law is about the relationship between applied force and also extension. So normally we see the concept of the spring lah, correct or not? Or you put a load of 1 Newton. So it will extend, correct? If you put 2 Newton, then the spring will keep on extend more. So it's about extension, not the length, because sometimes students use the wrong terms also. It's an extension of the spring. That means you will keep on find the original length minus the one that how much. So it's called extension. So force applied is directly proportional to the extension provided elastic limit is not exceeded. Then from this graph also, you all know gradient refer to what quantity or not? I just want to see how many of you understand this topic. Because some students like, hey, yeah, man, we got learn this topic, man. So what can you find from this gradient? The gradient of graph refer to what? Yes, it's actually F over X. F over X is called spring constant. So this spring constant is like the characteristic of the spring or is similar like material like example, steel and copper. Which one will have higher spring constant? Yeah, steel will have higher spring constant, what? Correct or not? Because they are hard to stretch or compress. Bila susah diregang atau dimampat, maksudnya dia punya spring constant besar. Okay, pemalas spring. So why besar? Copper will be lower. That means that it easily stretch. Can get some idea. And lastly, we can also find another quantity, which is elastic potential energy under using area under the graph. So I let you all finish the definition first. Then I move on with the factor affecting. You all done already? May tell me in the chat. Now, in general, what is the SI unit for elastic potential energy? What is the SI unit? So normally you all will use Joule, correct or not? So therefore, if you ever encounter the force versus X graph, right, you careful the unit. Make it a habit, always change to what? Meter. You can do a remark. Why you need to change to meter? Because Joule is equivalent to Newton meter also. Newton times meter, not Newton cm. So a lot of times students will not write the final unit as Newton cm, especially structured question. Normally they will request you to find spring constant. So sometimes you all may find spring constant and then you may write Newton per cm, right, based on the graph. Can actually the answer. But then sometimes they might ask you to use the value of K to find energy later on. Then if you accidentally finally your answer you didn't aware, then you write Joule, then you use the value that is in terms of Newton per cm or in cm, everything will be wrong. So be alert lah. Objective question also like that one. A lot of times student press got one of the answer is in the calculator, but it's a wrong answer because of the unit. So this is also what I want you all to take notes when you all find based on graph questions. Jia tension is also in Newton. They are a type of force. Tension, frictional force, gravity, weight. They are just the different type of force only. You all finish, you all say done, huh? So about 10 people, then I move on. Okay, seems like, yeah. So I have to move on already. Okay, now next, factor affecting elasticity. Sometimes I will tell students now, we use the idea of the spring. Either the spring is more stiff or less stiff, better than using the term elasticity. Because if you base on the definition, elasticity means the ability to go back to its original shape and size. So basically, whether the spring is stiff or less stiff, basically they're able to back to its original shape and size if they do not exceed elastic limit. Okay, so this part very simple. We just need to tick only. So can y'all tell teacher which spring is more stiff? Shorter spring or longer spring? Means yeah. Yeah, because longer is easier to stretch, correct or not? Yes. This one no problem. How about diameter of spring? Now I already showed the diagram. Okay, diameter means refer to this diameter of spring. So which bigger diameter will be stiffer or smaller diameter less stiffer? Everything also I refer to stiffer. What do you think? Okay, some people say bigger, some people say smaller. Okay, I skip this one first. I skip this one first. Sometimes this diameter of spring harder to get the idea, okay? But I explain in a short while. We go to the third factor. Normally, third factor will be correct one. Thickness of spring. Which one stiffer? Thicker or larger diameter means thicker lah. This one thinner. So this one, obviously, right? This one, no one will make wrong, right? Of course, thicker lah. Correct. Now, basically, the second factor opposite. Second factor is opposite. That means the larger diameter will generally less stiff. Smaller diameter is more stiff. Now, normally I will tell students the example. I think you ever use the slinky spring before, teacher? When teacher show you all the wave idea, longitudinal wave, parallel, transverse wave. Yeah. So you all remember the one or you all play the colorful rainbow thingy. So is it easy to stretch or not? Yes, so they are not hard, but you try to take your mechanical pencil. Your mechanical pencil got the spring inside one, correct or not? Even though the spring, the diameter is very small, but then it's not easy to stretch on, So this is the difference. I hope you all remember, or you use the way that I tell you all this one. It's opposite from thickness of wire. Okay, then it will maybe helping a bit lah. Then lastly is about type of material lah, no problem lah. So then we move to the last questions. Could small round produce if using smaller diameter? Oh yeah, you can think that way also. More round. Means yeah, due to the curve shape, right? Oh, yeah. So up to y'all, as long as y'all know the idea. So last idea is normally this type of question is more toward objective questions lah. Okay, so there's they show you three identical spring. Then they also tell you original spring is 10 cm. And it will stretch to become 13 when you are loaded with 50 gram. But my system here is 100 gram. Then they want you to find what is the total length for this whole system. So whenever they want you to find the length of this system, or as you know, based on Hooke's law, right, the relationship is what? Force and extension, they are directly proportional. And how do we get force based on this idea is actually the weight itself. So generally, I always tell students the idea you can solve using ratio method because they're supposed to be directly proportional. So you no need to change the force using mg, then got a lot of decimal point, all this confusing. You can use the idea. If the mass is how much, what happened to the extension for one spring? Everything refer to what? For one spring. Okay, so you see based on the given question, they say what? When the load is 50 gram, what should be the extension? You all know what is extension? Compression also same thing. Yeah, stiffer confirm is a bigger spring constant. Yes. So, yeah, 30 minus 10, also you have 3 cm. Very good. So we always give the idea for one spring. Then what now? The system is subjected to how many gram? 100 gram, right? So it's double of this, right? That means the extension will automatically become how much? Yes, 6 cm. Very good. Okay, next we move on to here. So now what I get is if it is alone, one spring, memang it will extend how much? 6 cm. But if you have two springs in parallel, what happened to the system? You all know the idea? It's just very simple. If spring arranged in parallel, they will share load one. Dia kongsi berat tu. So what happened? The extension will reduce. Yes, they divide according to number of spring. So sini ada dua spring also 6 divided by 2. The extension automatically become like that, 3 cm. So if you have 3 spring, divide by 3. If you have 4 spring, divide by 4. Parallel. But if you individually then they don't count. But this is extension, betul? You also have your original length. What is the original length of this spring? You must take into account now they want the whole system punya length. So original, this one is 10. So this is also 10. So therefore, my total length x will be what? 10 plus 6, then 10 plus 3. So you got how many cm? 29 cm. So this is how you find the total length of a system. Is it hard? Okay, right? Is it confusing? Why 32? No, yeah. So we're done with this. So again, it's your time to solve the questions. Yeah, I show you 4 questions first. I go and check, is it a more question that I want to explain with you or not? But tentatively, you have this part first, okay? Tentatively, you solve this 4 questions first. Chapter 7, I forgot, I still write chapter 1, is from 5 1, process and motion. Evan cannot get your questions. How come we use CM for the series 2? Yeah, the top one is individual spring. One spring only, top one. Okay, you're trying to solve this question. You remember which worksheet? Okay, I show the worksheet just in case some of you a bit confused. 4.8. Yeah, this worksheet, this is what I refer. You look at the top part one, the title is Form 5, Forces and Motion 2, Forces and Motion 2. So you're going to do the lift system questions lah, which is number 4, 8. And moving on, the police system questions. Then the spring questions. Okay, Ken?